Good morning, grade 12. We're going to do chapter 3, hardware. Right, so we're comparing the we're talking about mobile technologies and comparing them with desktop computers, and also talking about the performance of a computer. So you must remember that specialist areas like programming, video editing and gaming, we prefer to use desktop computers, although the trend is to have mobile computers like laptops and cell phones and smartphones. Right, just to recap on the hardware, this section is quite interesting because it shows us up-to-date hardware components like biometric input data collection devices, scanners, touch sensitive pads, all input devices, and then you have game controllers as our input and output devices. Would be touch screens, game controllers, digital cameras, smartphones, smart boards, device surfaces, interfaces, So that's interesting that they have a section for input and output, and we know that touch screen is input and output, and there's a few others there. Then obviously the output devices, LCD and LED, and then we have the 3D printers as well for output. Storage devices, the normal ones, HDD, and your external hard drive, solid state drive, hybrid storage device, flash drives, memory cards, CD, DVD and Blu-ray drives, and then processing a CPU and GPU. Alright, mobile technologies. You can understand the smartphones. We have an on-touch keyboard that is smaller, obviously, than the standard computer, and touch screens that are smaller. And the difference, standard computers can be fitted with more RAM and faster processors. But smartphones also have RAM and processors, as we know. But they have they come standard with communication devices like Bluetooth and Wi-Fi. So they're better at connecting to the internet. Of course, they're easy to carry around and small, very mobile. And many tasks they can do. There are many tasks that are better suited to smartphones than computers. Reading messages and emails, reminders, checking the weather, updating social media, bank payments quicker and easier, Google searches, making voice and video calls and recording voice. It's easier on a smartphone and tablet. And they're also better at location-based computing, and we found in chapter 1 that location-based computing included the weather applications, food ordering, car sharing like Uber, augmented reality applications. That's all location-based. So smartphones will use a combination of GPS and mobile internet connections to provide service to you, and they're unique to mobile computing. Advantages, obviously, size and weight, easy to carry around, and you don't need a desk. But desktop computers are better at gaming and video editing. The number of tasks that mobile computers are performing are actually increasing steadily. Right, what is the negative part of mobile computing, like cell phones, smartphones and tablets and laptops? Basically their battery life and their computing power and power consumption all issue. Now the battery life is a problem. The power of the CPU is linked to your amount of electricity available to it. So your battery life is important for your CPU to work. And your battery needs to last the whole day. So every component in your mobile device has to be miniaturized. But the physical size of a CPU for a smartphone or tablet is almost the same as the physical size of a desktop CPU. But the smartphone and tablet CPUs contain many other components like a GPLT modem, Wi-Fi connector, RAM, Bluetooth connector, GPS tracker. But in the desktop, these components are separate. So in a desktop, all of those components there can be more powerful in a desktop computer than in a smartphone. The monitor is very tiny in a smartphone, so you can only display limited information, and it's not so suitable to use applications that require a large amount of information, like spreadsheets and word processing applications do not work well on a smartphone or a tablet. So the size of the keyboard is not suitable for large amounts of text input, and smartphones can't run the same CPU intensive programs as computers because there's also heat that is generated by all of these processes that have to run. And we know that a desktop computer, the CPU has a heat sink to cool down the computer, whereas a smartphone does not. Right, let's go to the next section, factors influencing performance. The CPU performance is the main thing that we worry about, the two factors. One is the speed of the CPU, in other words, the number of instructions it can complete per second, and then the other factor is the number of processes it can run, in other words, multiprocessing, and we all know that's about how many cores a CPU has. So instructions that the CPU can run per second is measured, or it's linked to the CPU's clock speed, given in megahertz or gigahertz. Millions of instructions per second or billions of instructions per second. Alright, so multiprocessing is important. The CPU might start stuttering if it tries to run too many processes at once. And then they talk about the GPU, the graphics processing unit, has a big effect on the performance of graphics intensive tasks. It doesn't affect the normal performance of your computer, but the GPU does affect your tasks like playing games or creating videos. Right, the two factors affecting a GPU's performance is the GPU clock speed, which is measured in megahertz, and the type of GPU. Anyway, memory capacity. So RAM can be too small, and then the computer will be slower because it's trying to switch between two applications, and the computer would need to remove previous applications from memory and replace it with new applications data. And if you don't close all the programs, then the computer might automatically close some programs for you, like this message will come up. Right, then we have CPU cache. They're talking about cache. It's a form of memory, and we all learnt about that. And CPUs now have small high-speed cache built into it, and the speed and the size of the CPU cache can have a significant impact on the CPU's performance. So we have CPU cache, we have disk cache, which is a small amount of RAM that's built into the hard drive. RAM that's built into the hard drive and stores data for a short period of time. Then you have web cache, which is a small area of the hard drive where images and pages from your internet browsing from the World Wide Web, those images and pages, remember, is part of the World Wide Web, not the internet. So that was quite, that's why they highlighted that word there, World Wide Web, because everything that you download and view is in the World Wide Web. We use the internet to use the World Wide Web, to get all the images and pages from the World Wide Web. Now, sorry, the web cache is a part of the hard drive, the computer's hard drive, a small area. It's going to be stored there. Images and pages are stored there for future loading, and it will make it faster. The computer will be faster to open the web pages. Right, secondary storage. Storage is secondary storage. Remember, RAM is primary storage. So secondary storage, the CPU doesn't directly access anything in secondary storage or your hard drive. It uses the input-output channels to access, the computer will use that input-output channels to get the desired data to RAM. We have other examples of secondary storage. We know USB, compact disc, digital DVDs, digital video discs, and external hard drives. So just examples of them. Then we talk about the speed of secondary storage. And we know it is slower than primary storage. Primary storage is RAM. Typically measured in milliseconds, and primary storage speed is measured in nanoseconds. So that's the difference. And then you have the rotating optical storage devices. The rotating devices are the CDs, the DVDs, and the HDDs, hard disk drive, which has they all have read-write heads. And basically, the speed of being able to find anything on those drives is called seek time. And then we have the rotation of the actual CD, DVD, or HDD drives. So seek time is trying to locate the area on the drive. How long does it take? And then we have rotational latency, which is the amount of time for a disk to rotate under the read-write head to get to a desired sector or section of the disk. And obviously we want the smallest time for both of those. And in order data to try and reduce that time, seek time and rotational latency, then data is transferred in large contiguous blocks. Right, we talked about disk caching, which is the amount of RAM that's built into a hard drive, and it basically stores data being sent and received for a short period of time, and if the same data is required, then it's taken from the disk cache. It's included as part of the hard drive or specified portion of RAM. Anyway, moving on to the network interface card, NIC. Now you can have two types. You can have an expansion slot on your computer's motherboard that you actually put in a network interface card, or you can have it built in as part of the circuit board, the motherboard. In other words, the motherboard comes with a built-in network interface card. Now you must remember the network interface card carries the MAC address. In other words, it's a physical address of a computer on a network. So when you want to join a network, every device has to have a MAC address. In other words, it's etched into the network interface card, and it's a physical address. It looks like an IP address, but it's not an IP address. It is the actual physical address. It's like we all have to have ID numbers. It's the same thing basically. When you want to communicate, when the computer needs to go on the internet or network, or even just a local network, then it needs a MAC address, and then IP addresses are given to each node, and the IP is a virtual address which gets changed, can be changed automatically if you set it to. But the MAC address is etched into the network interface card, giving that device a name, basically, to be recognized as. Then the basically, what else does it do? Well, it has a speed measured in megabits per second and so on, but it basically produces an interface between the computer and a network, and enables the computer to communicate. So your speed of your NRC can affect performance of your computer when it comes to loading web pages and downloading games, etc., and updates, copying over a network, or watching multimedia. So the speed of your NRC measured in megabits per second can have an impact on your computer's performance. And we're moving on to motivating a typical computer system in respect of user requirements. So your configuration of your computer that you're going to use depends on what you're going to use it for. If you're just going to be a home user, or a small office user, or a business user, or a gamer, or a power user. Well, home users, we know what we all do at home. We browse the internet, we post on networks, social networks, email, word processing, watching online and local videos, listening to music, doing all our work for school. We're our home users. Small office users do online research, sending emails and business communication, word processing, spreadsheet, note taking. That would probably be the teachers. And business users, yeah, if you are going to be if you're just a small office user, you're not necessarily needing a mobility, etc., but a business user would be more likely to want to be mobile in order to go to meetings, take computers with, and therefore their battery life needs to be good, and screen resolution to be able to view more information on your screen, and your speed. Computer must not decrease productivity, because business users are usually paid for the work they deliver. And then we have the gamers. Now, gaming computers basically use very high processing power with the CPUs and GPUs. One of the most process intensive tasks on computers, personal computers. So gaming is a good measure of a computer's processing power, and gamers are often used to benchmark computer hardware. In other words, see how the hardware items perform. Doesn't mean that all gaming computers have to be expensive. You can have different levels, as you can see, and different types of graphics cards, but it's important to build a balanced setup so that all components are at the same speed, roughly. It's not going to help you or your computer or the quality of your game if you have different speeds, if your CPU is much faster than your GPU, in other words, and also the RAM. You need the same is true if you have too little or too slow RAM. Right, now power users do advanced tasks like programming, web developing, video editing, graphic designing. Often you have two monitors. Obviously the processing speed and RAM are important for power users. Be able to run more than one application at the same time. Right, then selecting the hardware itself, I'm not going to go through that. Just remember that hardware manufacturers release new components every year, and they change. The strength and weakness of these components change every year. Do research on them using the internet before you buy components for your computer. Alright, moving on to that is it. Yeah, finished. Now you can do the quiz and have a good day further.